My name is Sir Forso, and good morning or good afternoon, as the case may be. During this webinar, I'm going to talk to you, well, hopefully with you, about advancing your cloud security journey, advancing your career, and several important topics pertaining to cloud security and cloud computing. Ideally, this will be more interactive of a conversation. So here within Zoom, please don't hesitate to open up the Q&A or the chat feature and ask a question as you have it, if you have it. This is really hopefully meant to be a bit more interactive as opposed to me just talking at you. With that being said, I don't have a lot of slides to go through. I don't want to do, death by PowerPoint. And also, I want to make sure I'm spending enough time talking about the few topics that I do have. So it's a bit sparse of a PowerPoint presentation on purpose because there's just a few things that they want to hone in on here to hopefully help you as you continue advancing your career and your cloud security journey. With that being said, I'm going to go ahead and jump right into it. The few topics that will be discussed during this webinar are, as you see here, we'll talk about privacy and data protection. We'll jump into compliance. We'll even talk about offensive security and moving your career forward, moving you deeper into your journey of becoming a cloud SANS cybersecurity ace and what that actually means. You have a few different choices, a lot of different choices actually here at SANS, but more importantly, as pertains to the world, your job, your career, your growth. That's really what I want you to get the most out of. How do you actually maybe get into this career or transition into it? And as you start moving into cloud security, what are going to be some of the most important topics? And of course, there's honestly a lot of topics in the realm of cloud security. Just talking about 3 or 4 or 5 of them right here doesn't do a lot of justice because it's extremely broad, just as is the topic of cybersecurity in general. There's so many different facets to cloud security and cybersecurity as pertains to where you can focus your interests, where you can focus your efforts, where you can actually skill up and learn a whole genre of knowledge that will be extremely helpful for you as you continue down your pathway. And that's the other really important thing, which is you, the audience. This is meant to be introductory to cloud, introductory to cybersecurity, and really thinking more about how you want to either get into this industry or move. Maybe you're already in security, or you're already in compliance, or you already deal with privacy, or you're already in IT, whatever that happens to be. Maybe you're starting your career pathway out right now and you want to learn more about cloud security. Kind of that as a backdrop for the audience is who I'm going to be trying to speak to. Well, it doesn't matter who I'm trying to speak to, I'm speaking to you. So hopefully you take the most away from this, regardless of where you're at in your career pathway right now. Just to reiterate, please do ask questions as we go through this, and hopefully we'll have a lot of fun as we do. Now, the first thing I want to talk about is privacy. Now, privacy in a cloud computing environment is what I think a very interesting topic because this is different than what we would traditionally see on-prem. When I say on-prem, I mean on-premises, as in the company you work for has a closet at the end of the hallway where your servers are located at, maybe a couple routers and some switches. And within there, you have all of your networking equipment and you have some cables, and that's like your on-premises environment. Now, of course, you get too big a company and you have a data center. You have a colo, maybe you own a couple data centers, or you're paying a lot of money for hosting your services in a more reputable location, dare I say, than the server closet. Now, to be fair, I worked in organizations that had server closets. I worked in organizations where we had data centers where I worked within the same facility where the data center was located, and companies where we had data centers down the road or across the country, and all the above. When you have that type of situation, though, you have your assets in that environment, as in you have servers, you have networking, you have storage, and you have all that in the location that you have physical access to if you're on-prem, as opposed to in the cloud, which is one of the fundamental topics of why privacy is so interesting in the cloud. Now, I do see someone raise their hand. Yeah, feel free to go ahead and ask your question, and I'll do my best to pay attention to the chat in the QA section. So go ahead, let me know what your question is. Although I don't believe you can unmute. So go ahead and just feel free to type it in. All right, let's see it. A chat.
Students have to use the Q&A feature, not the chat.
Oh, that's good to know.
Type it into the Q&A feature, and then we'll be able to see it.
All right, as you're figuring that out there on Zoom, use Q&A to ask any questions that you have. So privacy on-prem versus in the cloud. Now we're trusting a CSP, and that may be one of our first or second acronyms or abbreviations for tonight. Cloud Service Provider, AWS, Amazon Web Services, Microsoft Azure, GCP, Alibaba, Oracle Cloud. There's a lot to choose from. But the trust factor is the interesting part here, in my opinion, because now we're using a billion-dollar company in most cases. This is what we do. Those are huge companies that we all use, AWS and Azure and GCP and so on and so forth. And we're trusting that they're going to do their due diligence, that they're going to keep things online and running and confidential and as secure as feasible for us and for them alike. The other interesting thing here is it's not just trusting a large company with our data and reliability and availability, uptime, so to speak. It's also the fact that in something like a public cloud environment where, let's say, we create an AWS account, and within AWS, which is Amazon Web Services, we start using their cloud-based storage. Let's say we produce or create some S3 buckets or some EC2 instances or some Lambda functions or databases or containers or all the super popular services that people come to the cloud to generally use. Okay, so we're doing that. And the fact is that you're doing that, I'm doing that, and thousands of other companies here in the United States and abroad are all doing the same thing. And we're sharing the resources, as in the underlying fundamental physical hard drives and CPUs and servers are being shared amongst a bunch of different what we call tenants. And that's where, in my opinion, the other kind of concept here, privacy, comes into the conversation, because now it's like, how well is the CSP doing as it pertains to security and privacy of co-tenant activities? Like what I'm doing, what you're doing in the cloud, how is that going to differ and how is that going to be secured? All right, so there's a question or a comment here. It says how to identify data breach happened in the cloud. So when there is a data breach in the cloud, how do you identify that the breach perhaps happened? Well, it depends on your monitoring, how well your monitoring actually is. And monitoring is built upon typically logging and having a SIM, which is security information event management tool, ideally, or even cloud native services, which some SIMs are, and then alerting. And that encompasses what I call monitoring. So when you are under attack or you are breached, how do you know? That's your question. Like, how do we identify that? Well, the short answer is it depends. It depends on what the breach is. Like, if there was a spear phishing attack that led to compromise of an IAM account, that's identity and access management, perhaps the user accounts we use for GCP and Azure and AWS. If one of those accounts is compromised, what does that now look like? Does someone log in from an odd location? Does someone start making weird API calls? Does someone turn on the service that we didn't expect them to be turned on? Do they terminate things? Do they launch a ransomware attack? Any one of those, like someone creates a suspicious user. There's a encrypted message showing all of our files are encrypted and we have to pay a ransom to get it back. I mean, those would be two indicators of compromise right there, right? Something is turned off or turned on. There's some suspicious activity. So that would be an indicator of compromise, which I think is, between the answer of monitoring and IOCs, indicators of compromise, maybe the best way to answer that question. How do you identify the breach in the cloud? But other things like cloud native tools, as in you're going through the process of installing CloudTrail or Activity Monitor, or maybe more to the point of tuning them and getting value out of those basic services built into each CSP. So you are actively looking for suspicious activity, which takes, to be quite frank, a lot of time and effort to set that up properly, because you can go a long way in the world of cloud security and not end up actually having any quality monitoring in place at all. You'd be surprised how often that happens. So trust, zero trust, ideally, and then co-tenant activities and this whole sharing of resources becomes kind of an interesting topic in my mind in the world of privacy as pertains to cloud computing. One example of what that would play out to be would be what we call the hypervisor. And this isn't going to go in depth into virtual machines and and hypervisors and Zen and Hyper-V, but you can probably read that for yourself in the slide. And I want you to know it's very unlikely that a hypervisor level vulnerability will come to fruition to the point where an adversary can exploit that vulnerability to cause harm. The hypervisor, generally speaking, is the technology that every CSP has that, generally speaking, once again, is responsible for the sharing of the physical resources. So all the thousands or millions of servers and hard drives and CPUs and memory that the CSP provide to us, the tenants, that's all shared. And the hypervisor is the software technology on top of the physical servers that makes that sharing and isolation of tenant activities possible. Now, since it's software, maybe I shouldn't say it quite like that, but software typically has vulnerabilities. Let's go ahead and just say that. Okay. And if and when there's a vulnerability, like a critical vulnerability with the hypervisor technology that AWS is using or that Microsoft is using, and one tenant like you or I are able to break out of that hypervisor and break out of that isolation and gain access to someone else's assets, that's a big, big deal. Extremely high impact. Probability or likelihood is lower because that's typically software that's vetted very, very carefully by many organizations. That is the hypervisor software. So it doesn't typically happen. You don't read about that or hear about it very often. I don't, at least. And because that's low probability, high impact type of situation. And I mentioned public versus private. We're public, we're sharing of the resources with other clients or other tenants. And in a private cloud environment, we have just us with access to our cloud-based services. Now, which one of those is the right way, which is the most common way? I see both all the time, right? Extremely common. But back to finish up this kind of topic here quickly on privacy, it's super interesting because we're giving up fundamentally control. We're giving up control when we have shared resources and using the CSP's services. It's no longer something we have full control over. And once you start giving up control, you start giving up responsibility to security and privacy to an extent, which, like I said, is why I think that's interesting. Now, the next main topic here is actually that of data protection. Privacy, data protection, interesting topics, fun topics, and something that, once again, we have limited control over inside of our cloud computing environment. Now, let me back up and say, why does this matter? Why do we care about data protection? And I've been teaching and in the world of cybersecurity for 15 plus years now. And I kind of just assume no matter who my audience is, they always know, like, this is important. Like, I'm talking about it, so of course it's important, right? Otherwise, I wouldn't be wasting our time. So yes, it's important. Why it's important, however, is because huge companies, small companies, whatever size the company is, whatever industry you happen to be in, we all rely upon some form of data security and data protection in order for the business to be successful and have reputation and be able to continue moving forward as the entity chooses to. Without some type of protection of data, this is where we end up with a breach. And kind of to the question that I spoke a moment ago, this quote unquote breach, like that whole category, what's a breach? How's it going to happen? How are we going to detect it? How are we going to know we're breached? What tools do we have in place? I mean, there's a lot going on here. And I can't just give a quick answer and say, this is what always happens, because it's myriad different things that could possibly cause a data breach. And I'll just mention a few big ones right off the top of my head. That's going to be issues with IAM. That's identity and access management. Things like you are sharing the root accounts. Things like you haven't turned on two-factor authentication. Things like weak password complexity requirements. Things that also tie into IAM, like poor monitoring. Going back to the example I gave before, if someone does create a backdoor account or malicious account or account is compromised, what visibility would you have into that type of action occurring? Now, to be clear, it's a simple API call that you can look up in CloudTrail inside of AWS and see, oh, when someone creates a new account, this is what it looks like in the logs. You create an alert associated with that event, and then someone is notified when it happens. So worst case scenario, there's an IAM level issue. Someone does have weak credentials and the account gets compromised. That's bad, but it would be even worse if it happened and you had zero visibility into it. Now I see Vino has a hand raised. Go ahead and just ask your question straight in the Q&A section, and I'll be happy to answer it. As you do, I'll continue talking about data protection. That's really the backdrop of why, to help prevent breaches, to help ensure business moves forward successfully without having a compromise of confidentiality, integrity, or availability. So things are online and running, and we can trust that they're doing so in a secure fashion. So essentially all three of those things mean. All right, let me open up the Q&A and see what the other question is. I don't see any questions in the Q&A. But if you do have a question, no need to raise your hand, just simply type in the Q&A and I will answer that. So how do we protect data? I've answered kind of the why. Why do we care? Start with why. Now what? What do we do about it? What do we do about data protection? And the answer is what you see here on the slide. Generally speaking, as you can imagine, I'm not providing inaccurate information here. Ideally, I have some slides that actually pertain to what I'm trying to talk about. And encryption kind of becomes one of the main answers here to protect data. Now, we can't actually stop all attacks. That's not going to happen. We're not going to get to the point of 100% security. That doesn't exist. But what we can do is put protections in place to reduce the likelihood of a compromise to begin with. Now, encryption in the cloud, you see BYOK. If you haven't Googled that already, I'll just go ahead and tell you, it's bring your own key. As in, you hear encryption. Hopefully you've heard of encryption and you're understanding this is a way, it's a good thing, and when used against us, it can be a bad thing. If you're thinking about ransomware, that would be an example of encryption used against us, right? That's honestly, it's kind of what it comes down to. But we encrypt pretty much everything all the time in any type of modern cloud computing environment, even any type of modern web environment. Like right now, you're using Zoom. Zoom is over an encrypted channel. You're using a browser. You browse somewhere is over HTTPS. That's encrypted. You have a hard drive on your laptop that may be encrypted as well. You have a phone in your pocket or on your desk that's using iOS, which is the Apple operating system. And you have an Android. Doesn't matter who you are, you probably have one of those devices. And guess what? That phone, that tablet is fully encrypted at rest. Now, encryption at rest, encryption in transit, what I'm referring to when I say that, or when you hear about that or read it, is the fact that when the device is powered off, it's fully encrypted. So if someone steals your phone, it's a bad day once again, but it would be worse if they could simply have access to all of your personal files on that device. Encryption is the technology, the software that enables us to make it much more difficult for an adversary to gain access to the encrypted, well, the files on your device. Now, this pertains to cloud computing and cloud security because we have the exact same level of technology within our cloud computing environment. Clearly, it's not a phone, so it's not like an apples to apples correlation here, but there is, guess what? Cloud-based storage. This is going to be an S3 bucket. This could be a virtual hard drive. This could be many, many other locations inside of your CSP. When we do have some type of virtual hard drive or some type of cloud-based storage, there's also going to be a requirement to encrypt that at rest. So to reiterate, when the device or technology that we're using is turned off in the off state, all of the data is encrypted. All the data are encrypted. That's kind of the premise here. Now, what's interesting about that notion is the fact that if you're thinking through it and you think, well, my phone isn't fully encrypted, but my phone works really well. Like I can do everything I want to on my phone. I turn it on and I can do what I do on my phone. So how is this encryption topic, like, what does that mean again? It means when your device is turned off, it's fully encrypted. So back to the example of someone stealing your phone, or if you lose your phone. If it's turned on and unlocked, that's different. Same thing for a laptop, same thing for a virtual hard drive inside of Azure. Now, with that being said, you have to understand that protecting your data is paramount to security as well as compliance. We leverage things like full disk encryption and encryption at rest to help ensure that we're doing our due diligence, not because we're necessarily concerned that someone's going to break into an AWS data center and steal some hard drives and that our data is going to be unencrypted on those hard drives. That's one of those very low likelihood type of risks that would have, depending on how it was pulled off, maybe high impact, maybe low impact. You can leave that to your own devices to think why, but it gets very interesting. Once again, I think it's interesting. I think it's fun. Of course, this is what I do for a living, and I enjoy my career path, so all this stuff is fun for me. Now, security in transit and encryption in transit, that goes back to what I said about HTTPS. And as this pertains to a cloud computing environment, What you may not know is the fact that there are API calls occurring all the time. You log into your console or log into your portal inside of AWS and Azure respectively. You start making changes to your environment. Your company does this, your engineers do this, you do this depending on your job role, of course. And as those functions are performed, there's an API call associated with every single one of those things. Turning on a machine, creating a new account, deleting resources, turning on services. There's the unified application programming interface that makes all that happen. Now, all of those calls, all of those requests to turn on services and modify your environment are all over an encrypted channel. And once again, that becomes paramount for things like compliance and security as well, because without that, we have a very real risk of leaking sensitive information. So encryption in the cloud becomes critically important to the security of our infrastructure. Now, what bring your own key refers to is the fact that, okay, so we're encrypting everything. Hopefully, in this 5 minutes of conversation that has come across very clearly. Nowadays, in 2023 and beyond, we encrypt, or even 2024, I forget what year it is. We encrypt everything in transit and at rest. There's not a good reason to not encrypt it with today's technology and advancements in that technology. Now, when we're starting encrypting everything, there's a key. There's a key associated with this. There's an encryption key and a decryption key. Maybe it's the same symmetric key, maybe not. Usually it is. And we can bring our own keys into our cloud computing environment, as opposed to using the keys provided by our CSPs, our cloud service providers, we can choose to bring our own. And that becomes, once again, very, very important as part of the conversation of how you're going to roll out your infrastructure. And then, of course, redundancy, keeping things online and running, and ensuring that we have some strategy in case there is an outage. Just from a viewpoint of how this might actually look, as far as at rest or in transit, the different options here of maybe hard drives or databases, servers, your phone, your workstation, folders, cloud-based storage, all these when they're at the turned off state would be examples of encryption at rest. And then in transits is when we're moving something around from point A to point B, and we're ensuring that that channel of communication is encrypted. Like I said before, HTTPS and API calls in our cloud computing environment, and even file transfers. If you use something like Dropbox.com, for example, a software as a service-based solution, every time you upload or download files from that service, it's all encrypted as well. And that helps ensure that we have confidentiality and integrity of that data. Now, compliance is a type of topic where we're doing this, performing the function of compliance for the reason so we have a level of assurance that the security controls we put into place are implemented adequately. That's a fair way to say it. And not just us. This is also going to be the type of topic where we're putting this effort in to ensure that as we get scrutinized or audited by a third party or even potential client, that they have a level of assurance that what we're doing as pertains to cybersecurity is adequate or beyond adequate. So what controls are we putting into place? Encryption at rest, encryption in transit, IAM controls, like do we have two-factor authentication turned on? Now I said two-factor authentication or multi-factor authentication once or twice before. And that's the concept of when you log into your IAM account, your identity and access management account, you have a username, you have a password, and typically you have a token on your phone, which is the second factor of authentication. It's something you know, plus something you have, two different factors. Now, are we doing that? Are we doing that properly? Have we implemented it properly? Are there holes in our security program? And compliance, the role here arguably is to come in and answer those questions, identify gaps in our security program. How mature is our program? You bring this back to the question that was brought up before. And by the way, feel free to ask any questions you have. Now is an ideal time to do so. When there is a breach in our environment, how will we know about that? And if we don't have some instant response process in place, then it's going to be very difficult for us to be successful in answering that question. There's two things highlighted here, or at least noted in red, and that's security of the cloud versus security in the cloud. Now, what this refers to is the fact that there's a shared security and responsibility model in the world of cloud computing and cloud security. And specifically what I mean by this is our CSP, Cloud Service Provider, AWS, Azure, GCP. Those companies are responsible for security of the cloud, as in, have they put effort and performed their due diligence to ensure that the assets and the services they make available to us are reliable? Like, can we deploy cloud-based storage? Can we deploy a website? Can we use containers? Can we use whatever it is that they're offering as a provider and have a level of confidence it's going to work and run, like not have much outages, that there is security between co-tenants, that there is availability in different regions, things like that. So they're ensuring uptime. They're ensuring that there's level of security embedded into the services that they offer. Number one. Number two, security in the cloud. Now, what's security in the cloud? That's us. That's your company, your team, you ensuring that there's a level of security embedded into your security program. You have a security program, that you've rolled out security controls. That as you've gone through and done this process, there's confidence that it's being done properly, or has been done properly. Scott has a question. His question is, where do logs fit into this? Is it better to have a single SIM or multiple log aggregation in monitoring places, assuming some type of hybrid data center solution, partial physical data center extending into the cloud? Now, logs fit into this in a few different capacities. The first one is cloud native, as in Azure and AWS. Let's just use those two as examples. We have CloudTrail and Activity Monitor. Those are built-in services inside of Azure and AWS that will monitor what we call management plane logging. So when someone makes an API request, someone logs in, someone turns on a machine, all of those are examples of requests or actions that are logged by default. Now, where do those logs go? The answer is they stay within CloudTrail or Activity Monitor for 90 days by default. 90 days. Now, is that adequate? No. If you started your company 90 days ago or less, then yeah, okay, that is what you have. But other than that, no. So we have to end up moving those over to a security information event management tool. And that's going to be the ultimate location. That's what I like to say. So I gave one example of management plane logging, where you log in, you make requests to the API, those get stored in Activity Monitor and in CloudTrail respectively. But you also have endpoints, you have servers, you have containers, you have networking devices, and you have other cloud native services as well. All of those examples and more that I didn't mention will produce logs by default. And of course, we can produce some custom logs if we choose to. Now, as those endpoints and those networking devices and your web application firewall and you name it, as all those services end up being turned on and configured and running and producing logs, you ultimately want to get all of those sent to a SIM, a centralized, centrally managed location that you can then use to monitor. Because it's not us humans looking through millions of lines of logs every day and saying, hey, look, I found something interesting in that. Like, no, that's not how it works. There's a tool that does it for us. That's a SIM. And that aggregates all of our logs when it's set up properly. That's ideally where you should be getting to. I did see someone else raise their hand, and I'll go ahead and reiterate. Just go ahead and use the Q&A and type your question in there, and I'll do my best to answer it. But ultimately, you should have a SIM in place. When I say you should, like from the perspective of having a mature security program, that's ultimately where you want to get to. That's budget, that's configuration, and that's effort. It's not just like, oh, everybody has a SIM. Of course, that's the right obvious thing to do. Well, it's not always that straightforward. Okay, there's the ideal situation from a maturity program perspective, and then there's this is what we have, this is what we're starting with, and this is what we're going to do to begin the program. And ultimately, that's where you want to get to. Now, back to security in the cloud, the whole process of setting up that SIM, and sticking with the example question from a moment ago, because I think it's an awesome question, by the way, is going to be the tuning component, the purchasing component, the implementation component of turning on cloud services, making sure they work properly. That's security in the cloud. Amazon doesn't do that for you. Microsoft does not do that for you. If you have a website that's running and you are under attack Amazon's not going to come and save the day. If you have something in your SDLC process where there's a gap, as in developers are writing secure code or failing to do so, I should say, and there's a SQL injection vulnerability, and no one in your company has deployed a web application firewall, and there's no endpoint security as far as pertains to things like EDR, endpoint detection response monitoring, and things like that. Well, whose job is that? It's yours. We don't have the CSP doing those things for us. We're not paying them. It's not their responsibility. And that's, like I said, where it kind of gets interesting once again. Security in the cloud. Now, to help with this as pertains to compliance and other things as well, these aren't specifically compliance tools, but there is Defender for Cloud and Security Hub. These are both for Azure and AWS respectively. And what you can do with those tools would be things like ensure that as you start rolling out your security program, you have a level of confidence that you're doing so in a adequate way. And I'll show an example right here in just a second. Before I do though, this is the responsibility matrix. And here you can see from an from an on-premises versus infrastructure, platform, service, and function as a service, all those different perspectives there. You can kind of see who's responsible for what based on us, the cloud customer and provider, and whether it's shared responsibility or all of us or all of them. Now, let me give a quick example here of physical security. This is going to be like the Amazon data center. Amazon has data centers. They are 100% responsible for those data centers. That's going to be the cloud provider. If we're on-prem, that's our physical location. And as you can see, we're 100% responsible for security. As in, we're not going to go to the Amazon data center and jump over the fence and say, hey, Amazon, your fence is not high enough. And it didn't stop me from getting in. And by the way, you didn't see me. You're missing out on some cameras on the outside. And I didn't get chased by a guard dog. So you're like, that's not how it works. Like, that's clearly their responsibility. And it's 100% their responsibility as pertains to physical security of their assets. Now you start moving up a little bit and you see things like data classification, application controls, network controls. This is where it becomes a bit more of a shared responsibility model. As in, as we go through the process of having developers writing code, how well they're doing this from a secure coding practice. What other tools have we put into place that would help defend the application, help defend the network, help defend the endpoint, help defend the environment and business as a whole. And that's where, going back to the conversation that briefly brought up about budget and maturity, there's clearly a lot of things that can be done. One of those or two of those things, depending if you're using AWS or Azure or both, would be implementing Defender for Cloud or AWS Security Hub. Now, I have to be careful kind of how I approach this topic. There's no panacea. There's not like if you install one tool, then all of your security problems drift away. Not quite. It takes effort, it takes time, and there's multiple tools that you'll be using to help ensure the maturity of your program. Now, what you see here specifically in Defender for Cloud, for example, are things like SOC and PCI and NIST and CIS controls for AWS even, which is kind of interesting here instead of your Azure environment. What this is showing us is our relative security score pertaining to those regulatory compliance frameworks, those regulations. Like if you do here to NIST 853, or you are dealing with doing PCI DSS, and you're wondering, how well have we implemented security in our business? And if you use something like Defender for Cloud, you can assess your environment and get answers to those questions. Super useful from a compliance backdrop perspective here. Same thing in AWS with Security Hub, where we can actually run this tool, or posture management tool that is, and then get a security score and say, based on PCI DSS, we're not doing so well. We have a lot of different failures. And as you can see, we're not out of 100%, we're at 18%. A lot of critical, high and medium risk vulnerabilities pertaining to things like we don't have MFA turned on, multi-factor authentication, or we don't have CloudTrail turned on. We don't have basic logging in place. We have missing security groups, as in no firewall rules. We have SSH open to the world. We have all these misconfigurations that add up. And this harkens back to security in the cloud. These are the services we as a business have chosen to deploy, and therefore they're our responsibility to secure. That's the whole point of all this. Now, let's shift this conversation a bit and start talking about offensive security. Now, this is a topic that I brought up in front of a bunch of CISOs. I think it's like 2 years ago. It was last year sometime. And we went around the table, kind of like a CISO roundtable event, and kind of asked the question, what does offensive security mean to you? And I'll define it here just so we kind of have a level playing field, so to speak. What you see here, things like penetration testing and red teaming, those are generally regarded as offensive security. The premise being that there are adversaries who are actively trying to cause harm to your business and my business all the time. A lot of the attacks that we see start out as automated robots. Some of them are implemented, or we have humans behind those attacks that put in a lot of effort into causing breaches and causing harm to our business. And the fact is, it's happening all the time, whether you see it because you have good visibility and proper monitoring and logging, or you don't see it because you are lacking those things. Whether you know about it or not, it's happening. That's my point. With offensive security, to be clear, this is where we have a trusted partner, a trusted entity. Even our own company can be doing this. It could be engaging in offensive security operations, where since we're being attacked all the time anyway, it's going to be in our best interest to ensure that we have done our own due diligence to basically attack ourselves. Like, we'll do the work ourselves before the adversary does. That way we have some level of confidence that the controls we're putting into place are doing a good job. Like if we have firewalls, and we have secure coding practices for our developers, and we have security awareness training so people don't click on phishing emails, and we have anti-malware software, and we have redundancy, and we have all these other things in the world of cloud computing and cloud security. When we have those and we've implemented them hopefully properly, how do we know that we've done a good job? This is where someone will come in and do a penetration test. You have a third-party company or in-house people who will actively try to assess the level of vulnerability in your environment. That's what it comes down to. Identify the risk. You have vulnerabilities, you have gaps in your security program, you have things that aren't turned on, that aren't configured, that aren't doing very well. You have weaknesses. Let's go find those weaknesses before the adversary does. Because if we do it ourselves during a penetration test or a red team, which is like a longer simulated attack where like adversary emulation, like let's copy the tactics, techniques, procedures that real world threat actors are known for and see if we ourselves could break into our own company. That's essentially what it comes down to. That's offensive security. Now, the result of this is data. How well are we doing? I don't know. Let's do a pen test and find out, because I think we have a pretty tight security program, and I could be wrong. So let's see, if we were to be attacked, how would that actually play out? What would an adversary probably do to try to cause harm to our business? And that's what the focus of the penetration testing engagement would be. We have websites, we have servers, we have networks, we have all the above. And that's going to be what the penetration testers and the red teamers focus their efforts on to try to identify risk. Now, how does this pertain to cloud computing and cloud security? Guess what you're doing? Pen testing in the cloud. All right. Offensive security and penetration testing doesn't mean just only on-prem or something we did 5 or 10 years ago. This is ongoing all the time. Companies that have mature security programs perform these things on a monthly, yearly basis, depending on the scope of what needs to be tested. Now, in our cloud computing environment, we have things like infrastructure as a service, where we, as the tenant of that cloud computing environment, have chosen to deploy various resources and services, as in cloud storage, as in virtual machines, as in containers, as in databases, as in Lambda functions, as in you name it. And as we've already talked about and discussed, it's our responsibility to ensure that we've done so in a secure fashion. So doing a penetration test or performing a penetration test, whether we have in-house talent that can do that for us, or we hire a third-party company to be responsible, either way is perfectly fine. Those entities, your team or the company you hire, will actively try to understand how well you've implemented controls around Dropbox, which isn't even yours. As a software as a service solution, can someone break into your Dropbox account? And maybe that wouldn't be a common penetration test, but it's certainly something that people ask for consistently. And that goes back to, well, what control do I actually have over Dropbox? What control do I have over AWS? Like if someone tries to log into my AWS account, what can I do about that? Because it's once again shared. It's a shared responsibility model in that we don't have control over the console login page or the Azure portal login page. Microsoft and AWS respectively do. So there's some things we can do to enhance our security, and there's some things that they can do to enhance the security. Like I mentioned before, two-factor authentication, password complexity requirements, logging and monitoring in place. So if there is something suspicious, we're aware of it. Even things like geolocation fencing. So nobody from your company can log in unless you're doing so from the United States, as an example. Now, you have a pen tester come in and say, I'm going to go ahead and see if you've set it up properly. And they launch a spear phishing attack, and they get access to credentials, and they try to log in and say, well, yeah, you had two-factor turned on for everybody except for these 3 people. And I was able to socially engineer them to give you their password. That's just one example. Just one example. It could be you have a website running inside AWS. It could mean you have the deployment of your VPC, your virtual private cloud, in scope for your penetration test. You have a PCI environment, payment card industry, credit card processing. And inside that environment, you want to make sure that you're once again doing your due diligence. So you have a level of assurance that security controls are in place. That's where offensive security comes into this. Now, with things like vulnerability scanning, a question I get asked about a fair amount of the time is, are we allowed to do this inside of our cloud computing environment? And that goes back to the question, or even the point here, that these are shared resources. It's not physically our machines. It's not physically our network. Virtually it is. Like we're paying money as a tenant to subscribe to AWS resources. So what I want you to understand and take away from this is the fact that, yes, we are not only allowed to do penetration testing and vulnerability scanning, but if we're not doing it, it's not getting done. All right. Security of the cloud versus security in the cloud. As you start turning on services and using those services, there's risk, inherent risk that you're introducing to your organization. And if you're not putting the steps into place and the security controls into place to reduce that risk, that's going way back to the first question of this talk. That's how the breaches occur. Okay. So vulnerability scanning, red teaming, pen testing, these offensive security things should be part of your security program. These should be being done on a regular basis. And if you're not, you have gaps. All right. What do we focus on as pertains to your vulnerability scanning or your red teaming or your penetration testing? And as you can see, there's, as I mentioned before, things like websites and databases, your mobile apps, your physical apps, all of these potentially come into play as it pertains to the security posture of your cloud computing environment. Because guess where your websites and your servers and your databases are hosted at? And guess who logs in? You have computers and you have mobile devices, you're using some network somewhere. All of these fall into the category of cloud computing and cloud security nowadays, because this is where it's hosted at. This is where we log in to access and control resources. So this goes back to who's responsible for it. And it's going to be, once again, you if you deployed it. So it's interesting. There's clearly a lot of different things to focus on as pertains to security, and just by looking at this graph right here. And expertise, like who is in charge of the secure coding program at your place of business? Like, because that's where source code is coming from. You'd have developers writing code that ultimately choose to deploy this on a website that's linked to a backend database that's deployed in EC2 inside of AWS. So you have an infrastructure team or an engineering team or an operations team, as the terminology may be at your place of business, who are going to be responsible for implementing the cloud-based network, the VPC, the servers that all of this stuff resides upon. So you have expertise, developers, engineers, analysts. And of course, you have management, you have leaders, you have people that can understand risk and compliance and offensive security and put these pieces together to hopefully have a bit more maturity in the program that you are offering at your place of business. Now, how do you do all this? Like, how do you create a program that touches on all those different aspects? How do you implement security controls to a high level of maturity? How do you check to see if you have CloudTrail turned on? Right? Depending on where you're at in your career path, one or two of those may resonate more with you. Like maybe you already are in a management leadership position and you're trying to figure out how you can add value or what you can do to help secure an environment or what it would even take. Like, what does this process look like? What are the tools and controls in place that, or not in place, that you should be looking into? What I want you to understand is that cloud computing, this isn't a fad. Cloud computing's been around for well over a decade and it's not going anywhere, probably. It might morph into something else in the future, but right now it is extremely popular. It has been for quite some time. And I don't see that really changing because it works quite well. It's relatively affordable, it's scalable, and a lot of companies use it in one capacity or another. Like you can't really get away from cloud computing completely. You may not choose to use infrastructure as a service and deploy function as a service or deploy serverless or use EC2 or virtual machines. But guess what? You're using Zoom and you're probably using Slack and you're probably using Microsoft 365 or Google, and that's all exposure and that's all cloud. It's all cloud-based services. They may be software as a service, so you have less control, but is that a good thing? I was just teaching a class in Germany, a SANS class actually, and it was an interesting kind of dynamic in that it seemed like the general mentality on that side of the world was that the companies that are protecting their assets and doing a good job of doing so have a bit more trust in their own infrastructure and their own skills, their own teams, as pertains to security than they do with the CSP. And I've kind of got the opposite impression here in the United States, where a lot of the companies I've worked with and seen over the years are a hodgepodge of acquisitions and redundant machines and legacy servers, and they're happy to move to AWS or Azure, start off in a fresh, clean environment with no security holes to begin with. Like AWS can probably do it better than I can. Dropbox, like, why reinvent the wheel? Let me go ahead and just use why, why go through the process of recreating something else or all the effort of fixing something that's broken if I can just go somewhere else and use their service instead. So go back to the trust, go back to the security of the cloud versus security in the cloud. That's where it gets, once again, interesting. And to the point I'm making here, the fact that this does change over time and it's not going away. All right, so there's always something more to learn and super high demand. So I've probably mentioned 5, 10 different services, probably 5 or so different tools you can look into. Now, something like CloudTrail, Activity Monitor, if you're looking into logging and monitoring, those are tools, those are services that you should spend time learning more about. Things like Defender for Cloud and Security Hub, more tools, upskilling your pen testing program if you have one, or implementing one if you don't. Maybe even bug bounty programs would be an appropriate place to start for some folks. All these are kind of interesting things to look into, to say the least. Now, depending where you're at in your career, that's where you get to start asking the question of how do I move? How do I shift into the sector, or where do I start? Like what do I need to learn? And kind of answer that question, I want to shift this conversation over to what we at SANS have to offer. And as you can see on the left-hand side, there are courses. SANS, this is our career progression, we call our flight plan. It's basically our curriculum that focuses on cloud security. As you can hopefully see, we have everything from baseline, introduction to cloud computing and cloud security, as in if the stuff I've talked about in the last 50 or so minutes resonates with you and you want to learn more about it, and you can clearly see there's a bit of a learning curve, that would be the introductory course that probably be most appropriate for you. If you know what a CSP is, and you know what an API is, there's things like CloudTrail and so on and so forth, you start moving up to Sec 48, and then you have many, many other different classes that would be appropriate here. Note that there's a link being shared in chat, and also that, of course, the Q&A is open. If you have any questions about anything, please don't hesitate to ask. Now's, once again, a great time to do that. Now, the core, I'm not going to speak to every single one of these. I will highlight a few different things here, though. Like if you already are specialized, or you have a DevOps background, or you have a pen testing background, as you can clearly see, there's classes there that will be more appealing or less appealing to you. Sala asks, can you give example for data classification and accountability protection? Yeah, data classification. So, and accountability. So back to something like cloud storage. Let's go there. Let's say you're using S3 instead of AWS. And S3, you have lifecycle management, you have a responsibility to data classification, and even accountability for protecting that data. So what that might play out, or how that might play out, would be you or your team would be responsible for ensuring that maybe you have different buckets, which would be different storage containers, different storage accounts, even if you're talking Azure, that segment or isolate different classifications of data. So let's say you have public facing data, you have private data, you have credit card data, you have financial or healthcare information. Usually it's broken down by, we classify it based on typically criticality or sensitivity. As a, like public facing, anyone in the world can access this. It's publicly available, or very sensitive financial information. Based on the classification of that data, we're going to put protections and controls in place that we're accountable for to ensure that it can't be accessed by people that shouldn't have access to it. All right, and that's going to be things like having one-time links or having permissions for your cloud-based storage. So that would be like an S3 bucket policy, for example. To write that in JSON, which would specify who has access to the objects inside that bucket. This could be for cloud native services or for end users, as the case may be. But you need to start off by, kind of as your question alludes to, classifying what data should be in that bucket, number one, and then putting controls in place to ensure that only the right people have access to that storage. That would probably be how I go about doing this. Great question. Keep them coming. If you have any more, you're very welcome. All right, so this is like I said, the flight plan. If you're on your journey to becoming a cloud security ace, here's the different flight plan you have available to you. Other thing to highlight really quick are these symbols right here. These are certifications. So as you start looking at which class you want to take, if you are really focused in on walking away with the certification, some level of confidence to show your employer that you've gone through the process and you can answer questions like a person that has the knowledge, then you can get certifications for a lot of these classes, as you can see. The other thing I want to highlight just briefly is the fact that there's a lot of depth here, a lot of depth. Cloud is deep. There's a lot of things that you can delve into from a cloud compute perspective that fundamentally will also alter your trajectory on where your pathway ends up going, like what you're going to do in life as far as your cloud security career. And as you can clearly see, there's everything from monitoring to the essentials to web application to penetration testing, and even our cloud security for leaders course. So lots and lots of things to focus in on here, depending on what you want to do. As far as myself and this introductory to cloud computing, cloud security that we kind of had today, this dovetails, dare I say, very nicely into Sec 388. With Sec 388, this is, as you can see, the intro to cloud computing and cloud security. There's a few things coming up as far as classes. There's also an on-demand. So I want to draw your attention to that in case this is interesting, or you want to spend more time talking more about it, basically. The fundamentals, the vocabulary, terminology, breaking down a lot of those acronyms and abbreviations mean, how this stuff all works, backing up to saying, why do we care about this? Why is it relevant? And then moving into what are we going to do? How do we put controls in place? What do these controls look like? What solutions exist? What resources exist? What services are out there? What tools we look into? How does this all fundamentally fit together to ultimately, result in security for your company? And of course, career progression for you. That's the other huge takeaway from this, is what you want to do with your career as pertains to cloud computing and cloud security. And hopefully I've made it clear that there's a lot of choices for you and underneath the umbrella here at SANS. With that being said, I want to open this up to any questions and answers once again. Don't be shy. All right, there is another note here, and that's the fact that this is being recorded. It's going to be out there on YouTube, which is maybe where you're watching right now. I'm pretty good about responding to questions even after the fact, so don't hesitate to reach out. Once again, my name is Serge Borso, and that's pretty easy to Google if you can spell it properly anyway. That being said, here's my information. And I do see another question. Question says, is there any training you suggest on application security, securing web apps, APIs, and microservices? Yes, absolutely. And I'll back up a couple slides to show that to you. The class is Sec 522, and it's a SANS-based course, as you can imagine, that focuses on those three things you just mentioned. Web application security, web apps, APIs, and microservices, kind of the exact same thing you just asked about. And I personally have taught that class for years, and I can tell you that's pretty awesome class. If you're paying attention to the chat section here in Zoom, there's also a link to access that. Take you straight there. Very fun class, very in-depth. You're very welcome for that too. I don't see any other questions. If you do have any, don't hesitate to reach out to me. Like I said, I do a pretty good job paying attention to LinkedIn requests. I'm also on Twitter to a lesser extent. That being said, I want to thank you sincerely for your time. Hopefully you got some value or a lot of value out of this, and I hope to see you at SANS events and classes in the future. Best of luck to you.